All right, on this one, we'll have quite a lot of things to be thinking about, so I'll just whiz through them as quickly as I possibly can. First of all, what you have, let's point out what you've got here. You've got a circle, and you've got what is a quadrilateral in a circle, and all of the corners are touching the circumference of the circle. So we already know this is a cyclic quadrilateral. And what we know about cyclic quadrilaterals are, the opposite angles are supplementary, or they add up to 180. So this angle plus that whole angle here adds up to 180, and so on. This one plus that one adds up to 180. Anyway, let's read the question as we normally should do, and then decide what we're doing. Diagram not drawn to scale shows a circle. That's the center. That's always good. SG8 is a tangent, touches the circle. FOG is 118. DGS is 65. And then last of all, they want us to calculate, giving reasons for each step. For each step in your answer of the measure of OGF. So let's deal with that first. OGF is this angle here. So I'll just draw that in now. That's OGF there. Now, what I want to say about that straight away is, and these are my reasons. My working out's going to be all over the place again. Sorry about that. So my first reason is triangle OGF is isosceles. Now that's important to note, and if you want to know how I know it's isosceles, well, if this is the center, that's the radius of the circle, and so is this, which means that this line and that line have the same length. So that tells me it's isosceles. Now that I know it's isosceles, you might want to, I don't know, this probably be overkill if you then say, therefore this means that OF is equal to OG. If you want to, you can say it, but I don't really think it's necessary. I think you've already said it's isosceles, and that should be enough. Anyway, since we know it's isosceles and we know all the angles of a triangle add up to 180, so I'm going to say that OGF, that's angle OGF, is equal to 180, take away 118, and I have to divide that by 2. Reason being is because this angle plus that angle will be the same when they're isosceles. Okay, so let's do that. All right, so it turns out that that angle is 31 degrees once you finish working it out. For reasoning's sake, you might want to say this is only a 2-mark question, so I'm not really keen on doing too much work on it. But you might want to say that OFG, angle OFG, is the same as angle OGF because of the fact that you've already mentioned that it's an isosceles triangle. So that takes care of that. So that's that part done. So we can tick that off, tick that one off, that's done. All right, next thing is, this is 3 marks now. You have to think a little bit more for this one. DEF. So DEF. So they want that angle up here. All right. Now, I mentioned before that this is a cyclic quadrilateral, and I also mentioned that in a cyclic quadrilateral, the opposite angles add up to 180. So where I've just drawn in blue, those 2 angles add up to 180. My only problem now is simply this. I already know from my calculations up here that this is 31 degrees. So all I now need to know is, what is this angle here? And if I know what this angle is, then I can add them together to get what this angle, what the whole angle is, and then I can take it away from 180 to get DEF up there. So hope you understand my reasoning. Anyway, let's crack on. Well, a few things I need to mention. I will do this in blue. I'm going to say, oh, this is part 2 now. I'm going to say DEFG is a cyclic quadrilateral. which therefore means that DEF plus DGF is equal to 180 degrees. All right, so I've basically stated now for my examiner that this angle plus that whole angle DGF, the whole angle, is 180 degrees. Now, what I already know about this is, well, I don't know, a few things really. So first of all, this radius here, when it touches where the tangent touches the circle, it makes a 90-degree angle just there. Okay, so I'm just going to draw that 90-degree angle in. That's 90 degrees. I already know that from there to this point is 65. So to find this little piece in here, I will take it away from 90 degrees. Obviously, I can't just jump and do that. I have to state that. So I'm going to say that angle OGS is equal to 90 degrees when a radius touches the tangent at the circumference. So therefore, angle, I've lost where I am, angle OGD, so I have to trace it, OGD, okay? All right, let's get that in there. Let's keep that where it is so we can see what we're doing. Therefore, angle OGD is equal to 90, take away 65, which is going to be 25 degrees. So I know in here is 25 degrees, which means that the whole angle, this whole angle here, is going to be 56 degrees. And now I can find DEF. So I'm going to now put down here and say, so this is my working out carrying on here. Therefore, DEF is equal to 180, take away 56 degrees, which is going to give us 124 degrees, 124 degrees. Right, so that's it, 3 marks in the bag. Even though I think this is worth more, about 4 marks, but they're stingy with the marks. All right, cool, so that's done. Hope that was pretty straightforward for you. Let's move on to part B of the question now. Now, part B of the question, let's have a quick read of that. It says, J, K, and L are 3 seaports. A ship began its journey at J. It sailed to K, then to L, and then it returned to J. The bearing of K from J is 054 degrees, and L is due east of K, and then they've given us some measurements here. Then the first thing to get the first 3 marks is easy. We need to just draw the diagram and label all the information, blah, blah, blah. Okay, cool. Let's go. Actually, let me not say blah, blah, blah. Let me see what they want. They want the north and south direction. They want that bearing, and they want these distances. Okay, that's fine. That's all blah, blah, blah situation. Okay, so let's pop this down here. First things first, before we do anything, we need a north line, okay? So I'm gonna start my north line, just make that look a little bit better. And once I got my north line, I'm just gonna label this as my north line. That's my 0 degree line there. And then, now bearing in mind, I am slightly, I don't know, because I think they might have loosely used this word draw, okay? That word draw, I think they might have loosely used it. Now, I could be wrong. You might need to talk to your teacher here in Trinidad to find out if they did, because usually the word draw means that you have to draw it accurately, so you need to be using a protractor and your rulers and stuff. I thought they would have said sketch, but I'm just sketching mine. Okay, actually no, I think they do need for you to draw it accurately, because now as I look further down the question, I notice they say calculate. Oh, it's actually no, I'm wrong. Calculate the measure. So if you have to calculate it, it means that you can just sketch it, because if you draw it to scale, they would have just said measure and state. Okay, and they're giving 7 marks to do all that. So yeah, I think that we just need to just sketch it, which is what I'm currently doing. Anyway, this point here is K, because it says, let's go back to the question. A ship began its journey, oh sorry, I do beg your pardon, at J. So we need to call that J. That's J. And then it sailed to K. All right, so what I'm gonna do now is I'm just gonna draw my line for that. I'm just gonna make it too long. Space is premium here. So remember that you measure your angle from the north line in a clockwise direction. That's your 054 degrees here. So remember, all bearings are measured from the north line and goes in a clockwise direction like that. So this is the new line that then gives us where K is. And then once it's sailed to K, the ship then sails to L and then returns to J. So let's find out. It says that the bearing of K from J is 54 degrees. We've done that. L is due east of K. So K is here. If I go this way, I'm going west. If I go that way, I'm going east. So I will need, just to make my point here, I'll need another north line going up there, just to be sure. So that's my north line there going up that way. I'll put in my north. And it's now saying that L is due east. So L is dead east that way. If it's due east, then this is a 90-degree angle there, because it's going due east. And this is now going to be my L over there somewhere. Right, let's see what else they said now. They said that JK is 122. So this line here is 122. So let's bring that up there. So that's 122 kilometers. And then it says that KL is 60 kilometers. So that's 60 kilometers there. And then what this ship did when it got to L, it sailed all the way back to, oopsie, let's do that again. It sailed all the way back to J, like that. So that red line is where the ship came back. All right, so we've got our first 3 marks, because let's just double check here now. We have the north direction. I don't really think you need the south direction. It's ridiculous. The bearing of 54 degrees and those 2 distances there. So I think we've got our first 3 marks. Then it says here, calculate the measure of angle JKL. JKL. So I'll just do that in black. That's the angle there. Right, well, that's pretty much straightforward in doing. I will use a few tricks to do this. There are many ways you can do it, but I'll just focus on one way, which is, in my opinion, the easiest thing to do at the moment. So what I will do is I will drop this further down. Well, look at that, I made a south line. So in case they wanted it, it's there. Right, I'll drop that down there. And what I want to say, parallel lines. This north line is parallel to that north line. And look, we've got that Z angle going on there, like that. See, Z, Z, Z. So they're alternate angles. So that basically tells me that this little piece of an angle is 54 degrees as well, because it will be the same as this angle here within the shoulders of the Z. Now this line I've brought all the way down here straight. What can I do with that? I know that this is 90 degrees here, because remember that this went due east. So if that's due east and that's 90, it means that this is 90 as well. So I'm just going to put in my right angle shape in there to say that that's 90. So it means that that whole angle there is 90 plus 54. So what I'll do is, let's zoom this back out a little bit, and then we're going to say that you can do your working out somewhere else, whatever. So that angle JKL is 90 plus 54, which is 144 degrees. Okay, so that bit's done. Then they want us to find the distance JL. That's this distance here. Again, we'll have to use the cosine rule for that, because look at the triangle. We have a very big non-right angle triangle. We know that side and we know that side, and we know the angle between them is 144. So we'll use the cosine rule to find that length. For this, I'm probably going to move over to the side here so I can have some working out space. I don't know if you want me to sketch. Let me just sketch the triangle out again so that you can see it. So what we've got is something like that. We've got 122 there, 60 there, 144 in the middle there, and we are now finding this length there. So cosine rule is what's going to do the trick. So we're going to say JL square is equal to 122 square plus 60 square minus 2 times 122 times 60 cosine the angle between, which is 144. Make sure your angle is in, your calculator is in degrees for this. So I'm just going to pause the video and do the calculations. All right, this gives us a grand total of 30,328.008. I'm not even going to bother putting that in. And don't forget, you have to square root the answer. So JL is equal to the square root of that answer, 328. And once we square root that, we got a grand total of 174.1 kilometers. Let me just double check something. They weren't specific as to how they want the answer, so they didn't say to 1 decimal place or anything like that, so that's fine. We'll just leave it the way it is. And last of all, now they want us to calculate the bearing of J from L. So we need to go to L and then find the bearing of J. So let's just make this a little bit bigger again so we can have a play with that. Obviously, we will need a north line there. So we're going to have a north line at L. Let's put our north line there. It's a very dodgy looking north line, but anyway, that's what we get for playing around with this north line. The bearing of J from L is going to be this whole angle going all the way around there. Okay, so we need that whole angle there. All right, this should not really be difficult. Okay, so but let's see what we've got. Let's extend this north line down like so. Okay, now that we've extended that north line down, I know that this whole angle here is 180 degrees. So that's pretty much some of my work done. So I'm just going to write that in. That's going to be 180 degrees. And the reason why I know that is because that's a straight line. Okay. The next thing is, what I need now, I've got a little bit of an alternate angle thing going on here again. See, alternate angle. But the problem is this 54 only goes to this line. I need to know this little bit of an angle here, and if I know that angle, I can then reflect it over here, and that will make my life nice and easy. That's one way I can go. I could possibly play around with a right angle triangle maybe up here, but I probably shouldn't do that because I don't have enough information to do that. So now I'm just going to focus my attention on just getting this angle just down here. And for that, I'm going to use sine rule to find this little angle here. So let's go back to my triangle that I've constructed earlier. Well, not constructed, the triangle that I sketched earlier. And that triangle is just here. And I want to find this little angle here. Now, I've already sorted out this bit, and I know it's 174.1. I can now use the sine rule to find this missing angle in the corner here. Now, to find that missing angle and using the sine rule, and I'll do the calculations in a different color so we don't get confused with it. So sine rule, I'll use 174.1 divided by sine 144. That is equal to, or you always pick sides and angles that you know or you want to find, okay? So I already know that side and the angle opposite it, so that's easy. I will not touch this 122 because it's only this angle that goes with it, and I don't need that angle. I need this angle here. So I will have to use the 60 and this angle down here. Again, I did not state the sine rule, just like I didn't state the cosine rule. So if you're not too familiar with it, you might want to go do a little bit of research on that, okay? Or check, see if I've got a video on it. I'm not so sure I do, but 60 over sine the missing angle 60. Sorry, got a little bit tied up there, so let's just do that again. So sine of the missing angle theta there. Okay, so now that I've got that, let's just reiterate. Side over sine the opposite angle, side over sine the opposite angle, okay, because that will be opposite there. Now let's do a little bit of rearranging to get what we want. We can cross multiply there, which will now then give us 174.1 times sine theta is equal to 60 times sine 144. All right, so what I'll now do is this that's multiplying will need to go over to the other side and divide. So now I'm going to have sine theta is equal to 60 times sine 144 divided by that 174.1. So let me just do a quick calculation here just to work that out. All right, so that gives us 0.203. And again, because we're trying to find an angle, we'll need to do sine inverse. So basically what we've got is sine theta is equal to that. So if you want to find the angle, you do sine inverse of 0.203. I hope for this whole time your calculator was in degrees, because if it wasn't, that would be a problem. So sine inverse of that is going to give us the angle being 11.7 degrees. Nice. So now that I know that that's 11.7 degrees, let's scooch back over here and say that I'll put this in black. This angle is 11.7 degrees, which means that that whole angle, when you add it to the 54, this whole angle here from there all the way there is going to be 65.7 degrees. Now that I know it's 65.7 degrees, like I said before, that whole angle will be the whole angle down here as well. So that whole angle is 65.7 degrees. And how do we know that? Is because of the parallel line rule. That's parallel to that. So therefore we've got the Z angle going on there, which is alternate angles. If you remember, if you've got parallel lines like that, that angle is equal to that angle, and so on. So that's what we've got going on there. But that's not our answer. Don't forget that it's a bearing you were asked for. So if I just zoom back out here, you were asked for a bearing of J from L. That 65.7 is only that little piece here. The bearing always starts at the north line going a clockwise direction. So basically you need to add that now to the 180 degrees to give you 245.7. So that whole bearing is going to be 180 plus that 65.7, which will then be 245.7 degrees. And you're done. And that's your 7 marks sorted. All right, so if you've got any issues with any part of it, just drop me a comment down below, and then I'll answer it back as soon as I can. All right then, hope this was good.